Okay. So Diana, I hope you can see the screen.
Yeah.
Okay. So in science class, generally we learn about three kind of subjects, or you can say we divide what all we learn in generally three categories. One is about the biology, that is about living beings, and the other things are about the chemistry, that is how various you can say objects or matters are formed. And third is about physics, that is physical world and how they are behaving, right? So in that category we learn various you can say topics. We have started with the simple topic, that is basically the magnets, because magnets is something which is already known to all the boys and girls. So you must have come across many magnets and magnetic things, but the world around us is basically using magnet in a big way. So we basically are learning today the amazing story of magnets and how they are ultimately used in our day-to-day life, right?
Can I get my laptop charger?
Yeah. Okay. Can I continue?
Yeah.
Okay. So start with the magnets. So question is, what is a magnet? So we already know that any object or piece which attracts some, you can say other objects, it is not able to attract all the objects, but there are some items which get attracted to it. So it is having some special power. Now we have a table, we have chair, we have pen, but they are not able to attract anything. But this piece, a very small piece, is now able to strongly attract some pins and some, you can say, items of, you can say, iron or something like that, right? So that means this piece of, we can say, material is having a special power. So a magnet is a rock or a metal that can pull certain metals towards itself without touching them. So it is having some invisible force. And we also are having some invisible force, which is called gravity, and because of which the earth is pulling us towards us, right? So there are two invisible force about which we are knowing or we experience in our day-to-day life. One is the earth's gravitational pull, and the other is magnet. So today we are going to learn about the magnetism. There is some invisible force, and that object which is having this force is called a magnet. So this pulling power is called magnetism, and a mysterious force like electricity or gravity. Now, what does it mean? It is acting at a distance. That is, even if your object is far away, magnet is going to attract it. And so this is the coolest part. Magnets work their magic through air, pulling metal objects from far away, right? So there are no strings attached, and still the objects are getting pulled away. Now, how the magnets were invented? So there is a story. This discovery story tells us that long ago in ancient Greece, a shepherd named Magnus was walking with his iron-tipped walking stick. So he came across a large black rock, and as his stick was having a cap of metal, it was sticking to that particular rock. So then he told the world that these are some of the rocks which are having some, you can say, invisible power. And as his name was magnets, the rocks were called magnets. And then the whole name magnet or magnetic material or magnetism was basically derived from that. His stick suddenly got stuck to a strange dark rock, and no matter how hard he pulled, the metal wouldn't come free. So this special rock was the lodestone. It is called magnetite. It is a permanent magnet and naturally occurring in the nature. That means wherever mines and there, these type of materials are already available. So this is world's first known magnet, and magnets discovery gave magnets their name forever, right? So that means in our nature, there are some regions, even when you go across some places, there are some magnetic regions also where your car also get pulled away slightly without touching the steering wheel. So I'll show you after this presentation some videos where you can see that the magnetism of the rocks is so strong in certain region that the car is also moving without you can say any effort from the driver, right? So though he is not driving, the car is attracted by the magnet. So magnetism is there even in the nature. Now, how magnets work? So the magnetism is basically created by the uh, spinning movement, right? So what is spinning movement? That is moving around and round. So we know that everything around us is made up of incredibly tiny building blocks called atoms. And inside these atoms, there are several smaller particles called electrons. These are the smallest particles which are called electrons. And these electrons, so this is the, you can say what is called nucleus. An electron is moving around us, around it in this, you can say closed part. So this is the electron. We have a negative sign. So it is spinning. And because of this spinning force, this are called protons over here. So nucleus is protons, it is positively charged, and electrons are orbiting around us. And this is the model of atom we have over here. So every matter is made up of this type of atoms. And so the spinning movement of electron, they ultimately produce the magnetism force. Now it is, that means suppose this atom is producing magnetic force in this direction. If the materials are such that all the atoms are producing magnetic force in same direction, then such materials behave or they have this property of magnetism. Why not all materials are because all the materials are having atoms and electrons and everything are there in every matter, but not all the materials are showing the magnetism, right? Because in some material one magnet is producing force in this direction, then the other atom is producing force in the opposite direction, so they actually cancel each other, right? It's like you can say you are pulling rope from one end and your friend is pulling rope from the other end in opposite direction. That means if you're both are pulling in a same manner, that means with same force, the rope is not moving in any direction, right? So the force cancelled out. So that is what happens in most of the materials. But in some of the materials like iron, nickel, cobalt, there are some materials that net force is there in one direction, and such materials are the one who are having magnetic properties, right? Do you understand, Diana, what I'm trying to convey?
Yeah.
Okay. So when millions of electrons in a metal all decide to spin in the same direction, something magical happens and they create powerful force. This teamwork of spinning electron is why metals like we already had discussed iron, nickel, and cobalt. These are the, you can say, very common magnetic materials. So these are the materials which are either getting attracted by magnet, or you can make a magnet out of it, right? So magnets are very common, and the property because of which they have this magnetic force is the spinning of electron in a particular way, so that they are all, you can say, producing an invisible force in one particular direction. All other materials are not having this property, and that's why not all the materials are having the magnetic attraction force. Okay. Now we already have the, you can say, permanent a magnet with us. So what are the parts of magnet? So magnets basically is generally having two special ends. They are known as poles. So every magnet has two ends called poles. A north pole, usually painted red. If you already have it in a lab or you're in a school, if you have a magnet, so that will be painted red, the North Pole, and South Pole usually is painted blue or green, right? What is this property? So suppose I have a bar magnet, it will be something like this. So you will be having North and South. Such magnet will be there. So this is called a bar magnet. And this part generally is painted red, and the other one is painted blue, right? So this is how a magnet looks like. So what do we know? Magnet is having two poles. This is called North, N for North Pole and S for South Pole. Now, some unique properties we have. North, they repel each other, that is push away, and the opposite pole. So North Pole is always getting attracted by the South Pole. So the amazing rule is that opposite poles pull towards each other like the best friends wanting to hug, and the same pole push away, right? So that if there are not poles of two different magnets are coming near each other, they will push away each other. That means they get repelled. So this is the property which is used to basically say what is say for getting the directions. You know, in ancient China and all, so people when there was no Google Map or there was no GPS available, so people used to travel with the help of the sun. That means in the daytime they were getting the direction through sun's direction, because sun rises from the east and sets in the west. So from that, they came to know about the direction of what is north, south, east, west. Or in the night, the sailors were getting direction through the position of stars, right? So they were getting some rough information from that. But then later on, they had a device known as magnetic compass. So compass is having needle, and this needle is pointing towards the north. So from the position of needle, we can find out what is the direction of north, and to the left of it we have west, and to the right of it you have a east, and the opposite side is south. So magnet was basically using this property. So when a magnet is or magnetic needle is suspended, as Earth is also a giant magnet, so the needle is always pointed towards north-south pole of the Earth, and that's how we came to know about the directions. So this property that these two poles attract each other, opposite poles, and rather you can say the same poles repel each other, was used to make a unique device called magnetic compass. This magnetic compass is was the very popular these days. Also, it is very popular because that magnetic compass does not require any. Suppose you are using your mobile for your Google Map or some GPS application, it requires power. If the battery goes down from your mobile, you will not be able to find direction. But magnet or a compass does not require any power. without any electricity, it will be able to show you the direction, in which direction if you know that you want to go east, you can find the direction east using compass, right? So that is still very, very useful in remote locations where there is no electricity available. When your battery of the mobile dies, there also you can go with the help of the what is called magnetic compass. Okay. Now we already know the south poles, opposite poles attract, and the you can say that we already discussed. Okay. Now, magnetic materials versus non-magnetic materials. So, what we had already discussed that the materials like iron, nickel, cobalt. Just a minute. The materials like yeah. So iron is there, cobalt is there, and nickel, they get attracted to magnets. And these metals contain special properties. They respond to magnetic force. We already had learned. So there, the spinning of the electron is in such a fashion that they togetherly produce the invisible magnetic force in one direction. While in other materials like wood, plastic, rubber, aluminium, they have a random, right? So one atom is pulling in this direction, the other is pulling in this direction. So net effect is canceling each other, and so there is no magnetic force. So in our day-to-day life, we are having many objects, but wood, plastic, rubber, aluminium, glass, they do not attract. They do not get attracted to magnets, or um, you are not able to make magnets out of these objects, right? So in world there in our day-to-day world around us, whatever we have, some are magnetic materials and some are non-magnetic materials. And what are the magnetic materials? The three very popular magnetic materials we have over here is iron, cobalt, and nickel, right? What you can see over here, these two kids are also observing what are the magnets and what are the non-magnetic materials. Now, what we are supposed to see is that Earth is also a giant magnet. Now, it is also mystery why Earth is a magnet. But you can see there are, you can say, Earth in the center of the Earth, there is a magma, and then there are some circulating currents. So maybe Earth is made up of large molten iron and other things. So it is also making it magnet. So our Earth itself over here, if suppose we look at this Earth, which is a spherical shape. So this is the North Pole and this is a South Pole. So in a way, we can see that Earth is a giant magnet in this fashion. Of course, geographical net north and magnetic north are having slight, you can say, difference. They are at slightly different locations, but more or less for us, north-south of magnet and north-south of Earth are at the same direction. So we are actually living on a massive magnet, which is called Earth. Deep inside Earth's center is a core packed with hot liquid iron, and that creates a giant magnetic field around our entire planet. This is why compass needle always points north. They are following Earth's magnetic lines, just like iron filings around a bar. For thousands of years, brave sailors and explorers used this amazing fact to navigate across the oceans and find their way home. Right? So we are able to use compass because our Earth itself is a giant magnet. Okay. So how a magnet works? The invisible magnetic field which we have over here is nothing but the region in which if other magnet comes, right? It's like something like that. Suppose you are having a range. and in that particular range, if you enter, you are getting pulled in. So that invisible range is called the magnetic field. So magnets create an invisible area of influence called magnetic field that extends around them in all the directions. So this field can pull magnetic materials towards the magnet without the magnet actually touching the object, right? So suppose I have a magnet like this. Suppose I have a magnet like this. This is north and this is south. Then the magnetic lines are assumed to be in this fashion. Yeah. Jana, are you asking something?
Huh?
Are you asking something?
No.
No.
Why is it? Yeah.
Okay. Are you able to hear me?
Yeah, I'm able to hear you.
Okay. So we assume as if some invisible lines are coming out of north and they are going towards the south. So this is the region in which the other magnets or magnetic material experience a force is called the magnetic field. Right? So this is something which we cannot see, we can only experience. How do we experience? So you can see if you are having a magnet and just you can say bring a very small iron pin, or you can say what you have a metal pin near to each other. Then as you bring it near, once a particular distance is there, it will get pulled away. So this is the range in which it gets pulled away is called the magnetic field. So it is an invisible area around a magnet in which it is attracting other magnets, right? So that's why we say that there is an invisible field around, invisible space around a magnet, and that is called magnetic field. So the thing is that we are living on the earth. That means this invisible field of the earth's magnetic field is all around us. So we all are basically, you can say, affected by it. But the earth's magnetic field is very, very weak. The force which is exerted on it. So suppose I have a metal pin in my hand, so Earth's magnetic field is not able to attract directly towards it, right? So the Earth's magnetic field is very, very, you can say, rather weak, and that's why all the metal objects which are there on our house, they don't get pulled away by the north or south pole, right? So magnet is working in this fashion, and it is acting at a distance. This field can pull a magnetic material towards the magnet without the magnet actually touching the object. So it's like you are pulling some object without tying a string to it. If suppose I want to pull something, I need to either using hands I have to pull it, or I need to tie a string and pull it. So it's something like this. Suppose I have an object. I have an object over here and I want to pull it. So what will I do? So I will tie a string over here and then I will pull over here. But the magnet is able to pull without a string attached. So it is an invisible force, and that is very, you can say, a strange thing that that there is no touching and still it is acting. Now, the magnetic field or this force is strongest at the poles, that is two ends. So in this region, that is pole region, this region, pole region, the magnetic field is very, very strong. So the force of attraction is very strong at the two ends. It is called the magnetic poles. And in other area, it is comparatively weak. So this is how a magnet works. Now, how do you make magnets? So the thing is that sometimes you can say magnets are naturally available in the mines or in rocks or in the mountains. So they are called the natural magnets. So natural magnets are found in nature as a special rocks like lodestone and magnetite. These are Earth's original magnets. So they are natural magnets occurring, and you are not. Nobody has made it. The only nature has made it, right? But then there are some other magnets also. right? Rubbed magnets. If you have a metal pin and if you have a magnet with you, you can rub a magnet with that particular metal pin. And once you rub it for short duration, that metal pin will also be behaving as a magnet. So that's called rubbed magnet. So it is made by rubbing metal objects with the strong magnets, causing electrons to line up in a same direction, right? So you can rub a magnet on a metal pin and you can make temporary magnets out of it. So that is called rub magnet. And there is one more way of making magnet that is called an electromagnet. So whenever suppose I have a piece of metal, you can say a kind of metal pin and something like this. I would like to show you in this fashion. Suppose I have a metal pin and if I wrap a wire, insulated wire on it like this, and if I pass current through it, if I apply a battery like this, and if I apply current through this wire, then the pin on which this wire is wrapped will now behave as a magnet in this fashion. So such an arrangement is called an electromagnet. So this electromagnet will be an artificially magnet and it will be behaving as a magnet only when you switch on the battery, right? That means whenever the current is flowing around the wire, using this, I can make a magnet. So see, these days, what all electricity you have at your home is made using huge power station or generating stations. So all the power stations or generating stations they have electromagnets. So electromagnets are having huge applications. In your home also, there are many devices which are using electromagnets. So electromagnets are a magnet using the electricity. So they are created using electricity flowing through wire coils. The coolest part is they can be switched on and off. So whenever you wish, you can make them magnets. And when you switch off the supply or electricity flowing in these wires, they will stop behaving as a magnet. So these are the electromagnets, right? So what do we summarize from this? That the in nature, the materials some materials are natural magnet and some you can make artificially by yourself. So this is the way you can make the magnets. Today's strongest magnets are made in laboratories and can be thousands of times more powerful than the natural magnets or permanent magnets, right? Now, where do we use it? We use these magnets at hundreds and hundreds of places. Now, once you know about this, you can say magnets, you will be able to appreciate the applications of it. And after this presentation, if time permits, I will show some videos also showing how magnets are used. So some are home helpers. Magnets keep your drawings on the fridge door and help cabinet doors stay closed. So you have a you can say at door also you have a magnet which is keeping the door open, or you are sticking something on the fridge refrigerator. So there you are using magnet at many places. Now, information storage. So, credit card and the hotel key use tiny magnetic particles to store important information. You on those all those cards, you must have seen a black strip. You can see, look at this. This one is the black strip which is there. So this black strip is the magnetic strip and it is storing the information. So this credit card people or bank people or hotel people, they load this information and once they permit, then only you are able to open or you are able to transact using the such cards. So here also the magnetic, you can say, property is used over here. Then in the third application, what you have over here is a giant electromagnets in the junkyards can lift entire cars and they are used in recycling center also. So suppose you have a car junkyard, right, where the cars are being crushed and they are basically scrapped. So there to pull. the cars, a very strong magnet is there, and you can say it just picks up the car and sends to crusher and all. Uh, Even whenever you are having some process material and you want to find out if there is metal hidden, so you are using the you can say metal detectors over there, and it is also able to find out if the metal is there. So whenever you go through any mall or you can say airport, there is a special frame through which you are supposed to walk through, right? And so there, one security officer is there who will check your body that if there is any hidden metal objects which can be harmful to the other passenger or the aircraft. There also the magnet or magnetic, you can say, detection is used. Then last one is the sound magnet, sound magic. So every speaker, that means the music you are listening to, the speaker is also using magnets, and this it is basically producing electrical signal, getting converted into the music signals, right? So if you happen to open out some, you can say, old speaker, that is a music box, then you can see a round, you can say circular magnet which is used on the surface of the speaker. So magnets are also used in this speakers or in the music box. Now there are some facts, fun facts. Magnets can temporarily turn paper clips and other metals into mini magnets by making their electrons like up in the soldier in the formation. So we already had learned paper clips. If you just rub the magnet on it, temporarily it will become magnets. Second is animal navigation. Amazing animals like birds, sea turtles, and even some bacteria can sense Earth's magnetic field to help them navigate during long journeys. Right. So the you can say there are some migratory birds. So they fly in a definite direction. Now they don't have any GPS or mobile with them. Still, every year in summer they go to particular direction, and in the winter they go towards these hotter places, right? So they are navigating. So they have inbuilt this property to sense the Earth's magnetic field. Third is the shapes. Magnets come in countless shapes: bars, horseshoe, ring, spheres, and even fun shapes like letters and animals. So I will show you many shapes of the magnet. Now, temperature is also affecting the magnet. So you can destroy a magnet by rather heating it or cooling it. So if you heat a magnet too much, it loses its power because the electrons stop spinning in the same direction. So suppose somebody wants to destroy the magnet, then also you know how to do it. You are supposed to heat it and then it will lose the magnetic property. The magnets are everywhere, from the phone in your pocket to the machines, the medical machines where the various scanning is there. You must have seen in movies or so. So somebody is having some injury, then he is supposed to sleep on the table. Then the table moves inside a CT scan and all. So they are all having the various strong magnets. So in medical field also, the magnets are used in a huge way. Scientists are discovering new ways to use magnets in amazing technologies like magnetic levitation trains. So you must have heard about the bullet trains or high-speed trains. So they are also using the magnetic levitation principle. The magnetic levitation means those trains are actually floating on the track. They are not actually touching. And that's why, as they are not touching, they are able to move very fast because there is no friction available. So high-speed trains, which are available in Japan and China, and I don't know many countries they are having, which are also known as bullet trains, and they are using the principle of magnetic levitation. And so ultimately, magnetic principle is used to run the huge trains also. Uh, just keep on observing what all the magnetic applications you have, and it will be very fascinating to know that. Now, making your own magnet. Suppose you want to make your own magnet. So, what do you do? Find a steel needle or paper clip or a nail and a strong magnet you can also get from a store. So now what you do, rub in a particular direction only, say from left to right only, not in a random direction. So this, when you rub the steel object with the magnets 30, 40 times, always moving in the same direction, you will be able to see that the metal object or a pin or a needle or paper clip which you have selected now is able to attract other paper clip. So now what do you see? That you have temporarily made it a magnet. Of course, it is not going to remain magnet forever. After some time, it will lose its magnetic property. But yeah, for short time, by rubbing, you are able to make them magnet. So this is something which you can do at your home. Of course, from store or maybe from your school, you have to get the magnet, and then you can do it yourself in your home. So you test your new magnet. You can also test your new magnet by keeping by bringing it near to other paper clips, and you will be able to see that it also gets attracted. Now, the magnet helps us find directions. How does magnet helps us in finding the directions? So what do we show? The on the right side, the figure is showing the magnetic compass. On this, there is a circular dial. Now, what you can see over here, there on circular dial, north, then west, then south, and east are already marked. And this is the pin which is free to rotate, right? When it is free to rotate and you keep it, you can say in a horizontal direction, so it will point where the north is. So Chinese sailors first used magnetic compass over 1,000 years ago, and they used to navigate these seas safely using the compass. How the compass works? A compass contains a tiny magnetized needle that always points towards Earth's magnetic pole. And Earth's magnetism, our entire planet acts like a giant magnet. We have already seen that with magnetic poles near the geographic north and south pole. And that's why the compass is able to point towards the uh, north direction. What is the fun fact? Earth's magnet poles actually move slowly over the time, and sometimes they even flip completely, right? So the north and south pole, because there is a molten, you can say, iron in the, you can say, beneath the earth, and that's why the earth magnetic poles are moving. So maybe say after some years, the north is over here and south is over here, and they also get shifted. So after some time, but it happens after thousands and thousands of years ago. So at present, in this present era of our knowledge, the north and south poles have not shifted much. But after thousands of years, it may happen that Earth's north and south direction may change entirely, right? So that time everything will change and the direction has to be labeled in a new way. Cool use of magnet we have already seen. Amazing magnetic effects. So electromagnetic power. So electromagnets can be 100 times stronger than the regular magnets and can be turned on and off by electricity. 3,000 miles of migration. Sea turtles navigate over 3,000 miles. How many? 3,000 miles using Earth's magnetic field during their incredible ocean journey. So they are not able to have they are not having any mobile or GPS. Still, they are able to move in a exactly same way and in a same location. And that's because of they have inbuilt navigation using Earth magnetic field. Now, temperature effect, heating a magnet to about 80 degrees centigrade can destroy its magnet by scrambling the aligned particles, right? So, temperature is also something which is very, very important. So, there is a fun fact at the bottom. Do you know some animals like sharks can sense electrical fields, while other pigeons have built-in magnetic compass in their beaks? Right? So, this is something which is observed in some of the animals and birds. Okay. So we need to keep on learning about the magnetic adventure, and that is how the journey, you can say, continues. Keep exploring. Magnets are everywhere around us, from the tiny ones in your smartphone to the massive ones in your power plants and research facilities. Next time you use a magnet, remember the ancient story of Shepherd Magnus and think about the incredible invisible force at work. Science is full of surprising waiting to be discovered. What will you explore next? We are going to explore next. We'll find out soon, right? So that was about the you can say magnet. I'll show you some of the you can say videos which are showing you the magnetic field.
Running a business isn't easy. So many decisions, tons of paperwork, but having the right tools can help save time. Ankur, can you take a quick look? Editing. Last minute. Fun with magnets. Class 6. Science.
Diana, are you able to hear to audio?
Learning objectives.
Yeah.
Okay.
Discovery of magnets. Magnets and their poles. Using a magnet to find directions. Attraction and repulsion. Types of magnets. Care of magnets. And uses of magnets. There are many stories about how magnets were discovered. According to a popular story, a magnet was discovered by a Greek shepherd named Magnus. It is said that the nails in his shoes and the iron tip of his staff got stuck to a large black rock on which he was standing. Greeks named this strange type of rock magnetite. The Chinese also knew about magnets. Ancient Chinese sailors used magnets for navigation. A magnet attracts objects made of certain substances such as iron, cobalt, and nickel. Magnets come in various shapes and sizes, such as horseshoe magnet, ring magnet, bar magnet, cylindrical magnet, etc. Materials that are attracted by a magnet are called magnetic materials. Example, iron and nickel. Materials that are not attracted by a magnet are called non-magnetic materials. Example, wood and plastic. When magnetic materials are brought close to a magnet, they do not stick evenly to all parts of the magnet. Most of them stick on certain parts of magnet. They are called the poles of the magnet. Magnetic forces are the strongest at the poles. There are two types of poles in every magnet, irrespective of its shape. These are called the North Pole, N, and South Pole, S. The two poles cannot exist independently. If we break a bar magnet, we would get two pieces, each having a North Pole and a South Pole. If a magnet is allowed to move freely, it comes to rest in a direction very close to the Earth's north-south direction. This property of magnet was used to find directions on the surface of the Earth by travelers. An instrument with a magnet, which is used to find directions, is called magnetic compass. A magnetic compass is usually a small box with a small magnetic needle at its center. This needle can rotate freely and always points in the Earth's north-south direction. Different directions, that is, east, west, north, and south, are also marked on it. Do you know why a freely suspended magnet always points in the Earth's north-south direction? It behaves like it is under the influence of another magnet. But where is other magnet? It is Earth itself. When two magnets are brought close to each other, they are either pulled towards each other or pushed away from each other. Whether magnets attracts or repels depends on which poles of the magnets are facing each other. When like poles of the magnets are brought close together, they repel. This is called repulsion. When two unlike poles of the magnets are brought close to each other, they attract. This is called attraction. There are types of magnets: temporary and permanent.
Okay, so Diana, this was the summary so far. What we can summarize in last few minutes, that in the world around us, there are some materials which show the invisible force. So they are able to attract some other objects like iron, nickel, metal pins like that. Such materials are called magnets, and the property is called magnetism. Some materials are naturally magnet, and some you can make. So artificial magnets are also known as the electromagnet. So by supplying electricity around a wire to some of the metal pins or something like that, you are able to make them magnets. They are called electromagnets. Magnets are always having two poles, north and south, and the magnetic field or magnetism is strongest near the poles. If you break a magnet, then also you are not able to separate out north south. The smaller piece will also have now north south, and the other smaller piece will also have another north south. So if I break a magnet into two, I will be able to produce two smaller magnets. That means you cannot separate out north pole and south pole. They will always be lying together. The other fun fact we have learned that Earth is a giant magnet, and that's why we are using magnetic compass to navigate the north-south poles of the Earth, right? And in our day-to-day life, or the world around us is using magnets in a big, big way. So magnetic field, magnetism, and magnetic materials are you can say, a very important topic of our life. And in science also, if you basically uh, in a university level also you make your career, you are going to learn about magnets and magnetic fields and magnetic materials in detail. Even the electricity is also produced using the magnets. So these are some of the things about which you are going to learn in your higher class. At grade 6 level, this is something which is sufficient for you to know that the amazing things which we have around us called magnets, right? That was all I wanted to cover today. If you have any doubts or any questions, you can ask. Do you have any questions, Diana?
No.
Okay, so I'll share the presentation so you can later on go through it. And so that's all from today. So I'm going to conclude today's class. I have a next class to do, right? Oh, bye for now. Good night.
Bye.